The big question now is, how will the netbooks be used in and out of the classroom? Well, one of the nice things about having a netbook for every student is that the software is uniform, so we only train them how to use one package of software to accomplish a task, whether that be capturing part of the screen, inserting video into a document they're using, or making a presentation using Prezi or using PowerPoint. So we only explain how to do it once. The problem with home computers is they have multiple applications that can perform kind of the same task, and they have different versions. So we have to give a lot more explanation and a lot more troubleshooting, but here all that's taken out of it. So now, once we get through those initial hurdles of training, we can focus on how the netbooks will be used in class. That is, how are we going to use it to enhance our teaching. So the next series of little video clips are going to describe some of the different ways the netbooks will be used as a tool in class to try to engage the students and try to get them to the next level in terms of what they're going to be expected to do and what kinds of things they can perform. One of the biggest challenges in the classroom is making sure every student is involved in the class itself. You ask a question, some hands go up, or some students answer, or maybe they write something down on paper, but you don't know what they're writing down on paper. This is the response that every teacher wants and every parent wants as well. Ask a question and all the hands go up with some kind of input. To help ensure that, there's this technique called just-in-time teachers that some teachers will be using. And this is combined with a personal response system, or what's often called a clicker. The way it works is pretty simple. A question is asked of the class. So here's a question where they're trying to figure out which picture shows the ball is moving the fastest. The students would then go to a Google Doc and enter what they think is the fastest, second fastest, third fastest, and have this ranking system. The students would then discuss with their peers their answer for about 2 minutes, and then after discussion, seeing what they have, they then go back and answer the question again and see if they have any change in their input. The teacher looks at this and says, oh, everything's going well, so I can move on to the next topic, or they might see some gaps, and the teacher would then probe a little bit farther into what's going on using this just-in-time teaching technique in Google Docs. Some experiments are too big, too dangerous, or too expensive to pull off in the classroom. So for that, we can use computer simulations to model the activity. This simulation shows a car going down a course, and there are certain triggers it has to hit at just the right moment so it makes it safely through the course, but enough to keep us interested. Students would figure out where those triggers go and then run through the simulation to see how it all operates. They would work collaboratively on Google Docs outside of the classroom with their calculations and their analysis to get the task done. This high-speed video is taken from one of the cameras that students will be using in lab. They can take this video, put it on a netbook, and analyze it using software on the netbook. They can find position, velocity, acceleration. Combined with some other information, they can find momentum, force, and energy, all from the video, just like the professionals use. Labs and activities are shared with the students through Google Apps for Education. It's kind of another version of Google Docs. What this provides us is a great collaborative environment. In the labs themselves, there are links so students can actually watch videos of how to set up or how to use different pieces of equipment, including the software. There are tutorials built into some of the links, and you can see how everything's very visual in the lab itself. Because it's a collaborative document, all the students in the group can work on the same document. They can work on it at school, or if they have access at home, they can also agree to work on it at home, and everyone can see each other's work on the document itself. So this is a great collaborative environment. The netbooks will provide access to information when the student wants it or when the student needs it. For example, this is typically what you might see in a textbook about Coulomb's law. Maybe that's what's going on in class. One of the things that makes this different than a textbook is the fact that there's animations, small animations that go on screen to draw your eyes and your attention to something they're trying to highlight. As I scroll down, I can show you how example problems will be different using the netbooks. This is a typical example problem you might see on the screen, in a textbook. As I scroll down a little bit farther, I can see a small solution to help me get going, and I can try it on my own. One nice thing about this is directly below the example, I can actually see a link to a YouTube video that's embedded into this page so I can see exactly how to solve it and have someone talk me through it. If I need a little more practice, there's also on the same page an interactive practice. So at this point, I can test out the forces myself and draw what I think the answer is going to be, and then I'll actually check it along the way. Since this little section is on Coulomb's law, perhaps I see something or I've heard something about a Coulomb blockade. And I think, well, that's interesting, I want to know more. Well, I have access to that. So I can go on the web and find out instantly as I'm thinking about this or as it's going on and mentioned in class. I can find out some information in this Google book, for example. Or perhaps I can find some other website to help me understand what a Coulomb blockade is. So the netbooks can provide this interesting access to information when I need it or when I want it.